वेलकम ऑल ऑफ यू बैक टू माय चैनल। तो जैसे कि आप लोग देख सकते हैं आज के वीडियो के जो टॉपिक है जी एडवांस 2021 सॉल्यूशन पेपर 1 क्वेश्चन नंबर 1 to 6। In the next upcoming videos we will try to cover the remaining questions of paper 1 and of paper 2। okay, so let's start। तो पहला क्वेश्चन आप लोग का स्क्रीन में है। यहाँ पर आप देख सकते हैं कि दो फिगर दिया गया है। पहले फिगर में ये है कि जब दोनों जॉ ऑफ ए वर्नियर कैलिपर टच हुआ है एक दूसरे के साथ तब का है, और दूसरा फिगर में है कि जब एक सॉलिड स्फीयर को वर्नियर कैलिपर के दोनों जॉ के बीच में रखा गया है। तो इन द फर्स्ट फिगर यू कैन क्लियरली सी द जीरो ऑफ द वर्नियर स्केल इज अहेड ऑफ द जीरो ऑफ द मेन स्केल। So here obviously zero error is there that you can see, okay, and as we know that the least count of vernier caliper 0.01 centimeter, therefore zero error will be minus 10 minus 6. Why I brought 6? Because you can see the 6 number division of the vernier scale coinciding with the main scale, okay, into 0.01, that will turn out to be minus 0.04 centimeter. Now we have to find the correct diameter, okay. Now the observed diameter from the second figure that you can see, observed diameter, okay, and that will be 3.1 plus 1 into 0.01, so it will turn out to be 3.11 centimeter. So the correct diameter of the sphere will be 3.11 minus 0.04, that is zero error, and it will turn out to be 3.15 centimeter. So आपका correct option है option number C, okay। So ये बहुत ही easy question था। Now let's move to the question number 2। क्वेश्चन नंबर 2 में है कि एक आइडियल गैस passes through a cyclic process consisting two isochoric and two isobaric process as shown in the indicator diagram। So the indicator diagram is वॉल्यूम, प्रेशर, और यहाँ पर 4 प्रोसेसेस दे दिया है। दिस इज प्रोसेस 1, प्रोसेस 2, प्रोसेस 3, प्रोसेस 4, एंड द क्वेश्चन इज इन व्हिच प्रोसेसेस डज द गैस absorbs heat energy, okay। So in the first process clearly you can see, in the first process, in process 1, clearly it's a isobaric process at a constant pressure and the volume is increasing, and if the volume is increasing, that is greater than 0, that means work done is positive, okay, and as the volume is increasing, that means the temperature is also increasing, that means change in temperature is also greater than 0, therefore dW, change in internal energy, is also positive. So from the first law of thermodynamics we can say that dQ is also positive, okay। So dQ is also positive, that means heat is absorbed by the gas during the process 1. Now in the process 2 you can see it is a isochoric process where volume remain constant. So in process 2 volume is constant, that means dV is equal to constant, okay, therefore work done is equal to 0, and you can see the pressure is falling in the process 2, that means the temperature is also falling, that means dT is negative, therefore du is also negative. So according to the first law of thermodynamics, we can say therefore dq is also negative. In the process 3, it is again isobaric compression where the volume is decreasing at a constant pressure. So here again we can say that the temperature is falling. Okay, so in process 3 also dt less than 0, that is negative. That means du is negative, and dv is also less than 0, that is negative. Therefore dw is negative. Therefore according to first law of thermodynamics, dq is negative. So in the process 2 and in the process 3 we have seen that the dq is a negative. That means heat is rejected by the system during the process 2 and 3. Now lastly in the process 4, in process 4 you see it is it's a isochoric process where the volume is constant and pressure is increasing. So here also in process 4 also what happened, the change in temperature is greater than 0, that is positive. That means du is positive, and here v is constant, so dw is equal to 0. So according to first law of thermodynamics, dq is positive. That means given to the gas or absorbed by the gas. So your correct option, that in which of the two process out of 4 the gas absorbed the heat, that means in process 1 and 4. So your correct option is C, that is in the process 1 and 4. Okay, now let us quickly move to the question number 3. Okay, so I hope you have understood, or if required you can pause the screen and look at the solution. Okay, now let's move to the question number 3. So this question 3 is given as your is a problem of the combination of two lenses, and you are asked to find the magnification. Okay, this is a concave lens, this is a convex lens, this is a concave lens, and the gap between the lenses are 2 centimeter. Okay, and an object is placed at a distance of 10 centimeter from the convex lens. Okay, so first of all we have to find out the focal length of each lens. Okay, first of all we have to find out the focal length of each lens. So it is given that the radius of curvature of each surface of each lens is 20 centimeter, and the lenses are placed in air having refractive index of the lens material 1.5. So by using lens maker formula we can find, say this lens is lens 1, this is lens 2. So the focal length of the first lens, that is for the convex lens, it is r upon 2 into n21 minus 1. So we can find it to be equal to 20 centimeter, and for the lens 2 it is f2 is equal to minus 20 centimeter. Okay, you know that the concave lens placed in air is having negative focal length, so it is minus 20. Now for the first lens you can see, for the first lens the object distance is 10, that means half of the focal length. So we know that if an object is placed at a distance equal to half of the focal length in front of a convex lens, then its image forms virtual and direct and forms at the focus itself. Okay, so हम लोग without any calculation हम लोग ये बोल सकते हैं कि the image formed by the first lens, that means for, you can just say for lens 1, u1 is equal to minus 10 centimeter, f1 is equal to 20 centimeter. Therefore v1 undoubtedly it is minus 20 सेंटीमीटर. ऑलराइट, नाउ इसका जो इमेज है ये समहाउ यहाँ पर फॉर्म होगा, एंड दिस इमेज विल एक्ट एज द सोर्स फॉर दिस कनकेव लेंस which is placed at a distance of 30 centimeter. Okay, now for the concave lens, for lens 2 we have object distance u2 is equal to -30 हम लोग ले लेगा, and the image distance that we have to find out, focus is equal to -20 centimeter. So by using lens equation we can find that -1 by 20 equal to -1 by 30, and that will be turn out to be v2 is equal to -1 by 12, therefore v2 is equal to -12 सेंटीमीटर. So clearly हम लोग ये निकाल लिए हैं. Now we have to find the magnification for both the lens. So for the first convex lens, magnification is equal to v1 by u1, therefore m1 is turned out to be 2, and for the second lens, that is concave lens, magnification v2 by u2, that will be 12 by 30, and that will come out to be 2 by 5. Now we have to find the total magnification, that is the product of m1 and m2. Understood? Therefore the net magnification m is equal to m1 into m2, and that will turn out to be m is equal to 0.8. So correct option is answer number option B. Okay, so you have seen till this question number 3 हम लोग बहुत अच्छा से without any hassle and without much more thinking or without much more logic we could done it successfully. Okay, now next let's move to the question number 4. So what has been given in the question number 4, that a heavy nucleus Q of half-life 20 minute undergoes alpha decay with the probability of 60% and beta decay with the probability of 40%. Initially the number of Q nuclei is 1000. The number of alpha decay of Q in the first 1 hour. तो पहले हम लोग लिख लेते हैं कि half life is given equal to 20 minute, and that is equal to 20 upon 60 r. Therefore the decay constant lambda equal to ln 2 upon t half, so it will be ln 2 by 20 into 60. इसको हम ऐसे रख देते हैं. Now हमको अभी क्या मिला है, टोटल 1000 है, वहाँ में से 60% न्यूक्ली है जो कि अल्फा डिके हो सकता है. तो पहले हम लोग निकाल लेते हैं कि 60% ऑफ 1000, दैट इज इनिशियल नंबर ऑफ न्यूक्ली अवेलेबल फॉर द अल्फा डिके, दैट इज 600. देयरफॉर बाय अप्लाइंग द रेडियोएक्टिव डिके फॉर्मूला we can find n is equal to 600 e to the power minus ln 2 upon 20 into 60 into time हम लोग को दिया है 1 hour, and that will after calculation come out to be 75. That means 75 number of nuclei out of 600 stay alive after 1 hour undergoing alpha decay. So number of alpha decay is equal to 600 minus 75, that is equal to 525. Okay, this problem you can do in another method also. Here given t half is equal to 20, okay, minute, and the number of nuclei available for the alpha decay is equal to 600. okay, and after 1 hour t equal to 1 hour हम लोग को दे दिया है कितना न्यूक्ली मतलब कितना अल्फा डीके हुआ होगा. तो पहले तुम ऐसे कर सकते हैं 600 आफ्टर फर्स्ट 20 मिनट comes out to be 300, and this 300 after second 20 minute comes out to be 150, and this 150 after third 20 minute comes out to be 75. That means 21 hour का बाद 600 से 75 रह जाएगा. That means number of alpha decay is clearly 600 minus 75, that is equal to 525. So the correct option is option number D. Okay. So you have seen this process also we can do, but this process is not applicable for every problem. ये problem ऐसे दिया गया था कि इस process से भी हो गया. Okay, now let's move to the question stem under which question number 5 and 6 comes, and here it is given that a projectile is thrown from some point on the ground at an angle 45 degree with a velocity 5 root 2 meter per second, and at the highest point the projectile fragmented into two part, दो part में fragment हो गया तो, and one part fall vertically downward and the other move apart. So it has been thrown with a speed of 5 root 2 at an angle of 45 degree. So the original trajectory of the projectile should be somewhat like this, but as what happened at the highest point, this get divided into two parts. One part fall vertically downward and another part moves forward and will fall at this part. So we have to find this x, okay, and the time after which the second part land on the ground. So we have already given that u equal to 5 and 6. So equation 5 and 6, u equal to 5 root 2 meter per second. Okay. So therefore we can find the total time of flight t is equal to twice u sine theta upon g, and that will come out to be t equal to 2 into 5 root 2 into sine theta means sine 45 1 by root 2 divided by 10, and that will turn out to be 1 t equal to 1 second. That means total time of flight is 1 second. Okay. नाउ यू सी तो ये जो सेकेंड पार्ट है, सेकेंड पार्ट कितना टाइम का यहाँ पर पड़ेगा. सो यहाँ से हाईएस्ट पॉइंट तक जाने के लिए टाइम लगेगा कि कितना, हाफ ऑफ दिस टाइम. तो बाकी रिमेनिंग मतलब कितना है 0.5 सेकेंड. मतलब जो सेकेंड पार्ट है उसको यहाँ से यहाँ तक जाने में 0.5 सेकेंड लगेगा. तो आपका पहला क्वेश्चन नंबर 5 का आंसर होगा स्मॉल टी इक्वल टू कैपिटल टी बाई 2, दैट विल बी इक्वल टू टी इक्वल टू 0.5 सेकेंड. नाउ वी अप्लाई the conservation of momentum we have to apply here, okay, at the highest point, so in the horizontal direction. Okay, so initially the momentum of the projectile at the point of projection, मतलब जहाँ से इसको छोड़ा गया है वहाँ पर initially horizontal momentum momentum होगा m into 5, because you can see the velocity 5 root 2 at a 45 degree, so the horizontal component of velocity will be 5. And at the highest point what happens, this projectile gets fragmented into two part of equal mass. So other part का mass क्या होगा m by 2 into इसका velocity मान लिया v dash, तो आप लोग को मिल जाएगा v dash equal to 10 मीटर पर सेकेंड. अब देखिए यहाँ पर हम लोग को क्या मिल चुका है t टाइम में, मतलब इतना टाइम में ये वाला जो सेकेंड पार्ट है हाईएस्ट पॉइंट से जाकर ग्राउंड पे लैंड होगा. ठीक है. सो इतना टाइम में इतना स्पीड से सेकेंड पार्ट हॉरिजॉन्टल डायरेक्शन में कितना दूर जाएगा. ओके, मान लीजिए इसका नाम हम दे देते हैं सपोज एक्स डैश. ओके, और ये तो होगा रेंज का आधा, मतलब जो एक्चुअल रेंज होता है उसका आधा. तो एक्स डैश क्या होगा, देयरफॉर एक्स डैश विल बी 10 मल्टीप्लाइड बाई 0.5 एंड दैट विल टर्न आउट टू बी 5 मीटर. ओके, और जो ये डिस्टेंस है रेंज का आधा है, तो r बाई 2 इज इक्वल टू कितना होगा 1 बाई 2, एंड रेंज कितना होता है यू स्क्वायर साइन 2 थीटा अपॉन जी. सो इट विल बी हाफ 50 इंटू 1 अपॉन 10, सो 5 2.5, देयरफॉर r बाई 2 इज इक्वल टू 2.5. तो हम लोग का रिक्वायर्ड x यहाँ से यहाँ तक x इक्वल टू कितना होगा, x इक्वल टू r बाई 2 प्लस x डैश, therefore x equal to 2.5 plus 5, x is 5, that is turn out to be 7.5 मीटर. सो आप लोग ये देखा कि हाउ वी हैव डन ऑल दिस क्वेश्चन वेरी इजीली. और जैसे कि मैंने एनालाइज किया पिछले 5 साल से जो जी एडवांस का पेपर आ रहा है उससे इस साल का 2021 का पेपर का डिफिकल्टी लेवल थोड़ा सा लो था, और हम लोग अच्छा से वेरी मतलब without applying much more technique and logic and concepts, we can easily do it. Okay, so in this video we have covered from question number 1 to question number 6 of paper 1. In the upcoming videos we will do the remaining questions of the paper number 1, and also we will take up paper 2. Okay, so I hope that you have understood it well. So keep studying and do well preparation for the अपकमिंग जी एडवांस 2022. ओके, बाय बाय.